Okay, welcome everybody to our second coding challenge. So let me make this a little bigger. So I've talked to kind of done a little round robin, and it seems like a few of you guys have worked on it. Maybe a few of you haven't, and that's fine, because what we really want to do is kind of talk through an approach to solving the problem. So this is the problem that we are working on. And you guys that have finished it, so I'm gonna, kind of ask some questions, kind of guide us through, but we don't want to jump straight to the solution. We kind of want to talk a little bit through how to approach the solution.
Are you trying to share your screen, or we don't see anything yet?
Thank you.
You said what?
There we go.
Okay,
Now you see my screen, right?
Yes.
All right, hold on. Let me.
I'm going upstairs watch my show.
Oh,
So you know I did
right
like
now.
some shirt.
There we go. All right, you guys can unmute yourself when you need to. All right, so good. So this is the problem that I had us look at. It's called two-sum. Given an array of integers called nums and an integer target, return the indices of the two numbers such that they add up to the target. Now, whenever you start working on a problem like this, the first thing is to make sure that you're really clear about what it's asking you to do. And one of the things, at least in most of these coding challenges, they give you some samples here. And so when you are trying to sort out an algorithm, that's what I start with, is trying to understand these examples. So actually, I am going to redo my little picture here. Let's look at this first example, just to make sure that we're clear about what we're trying to do. So suppose we have this array. My array is 2, 7, 11, and 15. And one of the things in the problem is it does say that we can assume that there is one and only one solution to this particular problem. So I have this array. And remember, every element of an array has a position in the array, or an index, right? And it starts at position 0. So this is position 0, 1, 2, and 3. So I'm given this array and the target is 9. So what we are looking for is two numbers in this array that will add up to 9. And if I find them, what I want to return are these numbers, the positions of these two numbers that I find. So in this case, if I have 2, 7, 11, 15, and the target is 9, then the answer is 0 and 1. And notice that it's returned as an array. So we have to find those two numbers and we have to return them as an array, right? So if, for example, if the target was 17 instead of 9, if the target was 17, then somebody tell me or type into the chat, what would be the solution that I would want? Where's my chat? Here we go. Yeah, they're telling me 0 and 3, right? Because 2 plus 15 is 17. And so that's what I would want to return, is 0 and 3, right? So how do we get started? Again, I don't want to go straight to, the most perfect solution. I want us to sort of think through, how do we approach doing this? So even if it's the brute force solution, does anybody have a suggestion of how do we figure this out? What's the first thought about how to do this? Because we're going to do this as a working session. Go ahead.
All right, well, we'd have to loop through the array
Right.
twice in order to compare the indices to see if they add up to our target.
Right. So that is a solution. And as I said before, sometimes just coming up with the brute force solution is the best thing to do to start with, just to kind of see what you're doing. So who was that? Carl was telling me we'd need to loop through this array. So let me see. I don't want to sort of code. I'm going to maybe I'm going to type in Notepad. Let's kind of talk through what we would do. So you're telling me that what I want to do, and I'm going to write this in JavaScript, guys. So I've got this array. Let's say the array is called nums. So I would loop through let I equal 0, I less than nums dot length I plus plus, right? So that's one loop. What's my second loop gonna do? Who was that, Carl? Talk me through how I would do this in this particular way.
Well, for the second loop, you would start with the variable j. So let j equals. However, you don't want to start at the indices 0 because you'll be breaking the rule of comparing the exact two elements. So you want to set j at I plus 1.
Yes, so one of the things that they tell you here, you may not use the same element twice. So that's a very good point that you just came up with. That means that I need to compare 0 to all the numbers 1 through the n. But when I get to 1, I don't need to compare 1 to 0. I've already done that, right? So we can make this a little more efficient here by saying, and also make sure that we satisfy that requirement by saying, let j equals I plus 1. And then j, same thing here, right? Less than the length of the array, j plus plus. So now I have these two positions in the array. So what do I want to do in here? Carl, or maybe somebody else, tell me in words, what do I need to do in here? I've got 2 pointers that I can use into the array. What do I want to do?
You could now check if the number I plus the number j is equal to the target.
Right. So that's just an if statement, right? So if nums I plus nums j equals my target, then what is it that I want to return? We need to return those two numbers as an array. So can I package them up as an array?
You could return them as just use the I and j since they represent the index.
Right. So that's all we need to do is just return those two numbers, right? And that's the end of my if statement. And that's the end of this loop. And that's the end of this loop, right? And I think I actually did that initially. I'm going to show you guys. Let's see. Well, let's actually, so I'm going to code it over here because I want to show you guys how I would test this out. So when I'm doing these problems, I actually like to code them separately. I honestly don't like to code them on the site. I like to kind of set up my own little test bed to test it out. So I'm going to do this here. I'm going to make a function called toSum, and it's going to receive an array and a target. And we're going to start with this brute force method, because then we want to talk about a way to make this much more efficient. So we have for let I equals, I should just copy this from over here since I have it in Notepad. This will work. So let's copy this over into here. Fix my indenting. So this goes here, this goes here, goes there, then we check and we return. Do I have all my brackets lined up right? This one goes over here. That's what the problem is. That one goes there. This one goes here. All right, so I think I'm good. Sometimes, depending on what, I need to close this one up. All right, I think I have, no, I'm still missing. I've got one too many. There we go. All right, so I think that's what we have. Now, how can I test this? So I'm gonna make a little test array over here, right? So I'm gonna make let tester, I'll call it test array equals, what's my little test case over here in LeetCode? We did 2, 7, 11, and 15. So we'll do that. Two, 7, 11, and 15. And I can call this, and we can console log out what we get. We call toSum, we pass it this array. And we're gonna pass it 9 as the result. And we'll see what we're gonna get here. So let me save, let me open up, let me make sure that I've got, this is what my index file is looking at. There we go. Yeah, I'm not looking at the right. I need to change this to the one I just did, which is called leetcode. Okay, so that's what I want to run here, leetcode. Save all. Let me open this up with live server. Look at my console. All right, so look, I got back an array and I got position 0 and position 1. So that's what I expected to get as an answer, right? We can test it maybe with something a little different just to make sure. So let me test it with, here we go. Let's say that we're looking for 17. 17, remember, is going to give me the first one and the last one. So let's see what happens if we run it with that. So we get 0 and 3, right? So it looks like it's working, but what's the big O of this solution?
It's N2 because you're looping twice.
Yeah, so n squared, right? Because we're
Yes.
looping through the whole thing and looping through again, although it might be a little less because we're not looping through the entire array the next time through, but it's still approximately n squared. So now I want to think about how can we make this more efficient? What can we do? So did anybody have a more efficient approach to this? I know what I want to say, but I want to see before I start if anybody came up with a more efficient approach to it. Okay, so let me talk you guys through. The way to approach this more efficiently requires using a data structure called a hash map. Because what a hash map or a hash table allows you to do is to store key value pairs. So kind of, and I think in Python, you do it with a dictionary, Mike, I think, keep me honest here, but I don't do Python real quick.
Yeah, that's right.
At the top of my head. So the idea is, let's kind of think through the thought process here. So, because what we want to do is we want to figure out, can we do this with just one loop through this array, walking through this array just one time? So my first number is 2. And let's say in this case, my target number is, actually, I want to change it. Let's move the 7 over here so we don't find it right away. All right, so let's say my 7 is here. This is whatever, 8. And the number that I'm looking for is 9. So when I look at this 2, what I want to think about is this could be a solution if I could find its match, right? I need to think about what number would I need if this was a part of the solution. So if I'm looking at 2 and my match is 9, then the match, or we'll call it the pair. What's the other number that would be the other pair to this? Would be 7, right? And so the question that we actually want to know is there a 7 in this array? Now, we could go search for it, but that still is going to be still walking through the whole array again. So we got to realize that sometimes we may not find it until we've kind of walked through. So I need to keep a list of what values have I seen and what position is it, right? So right now that list is empty. There's nothing in it. So I look at my 2 and I say, have I seen the number that I'm looking for? Have I seen a 7 yet? No, I haven't. So what am I going to do? I will add this number to the list of what I've seen, right? So we're going to add in that we know that a 2 can be found at position 0. Let's just that's the way I'm going to kind of put it in here. Okay. And I keep going. So I go to the 8 and I say, okay, if 8 was a part of this solution, which number would I be looking for? So that would be 9 minus 8. So I'm looking for a 1. So I go, is there a 1? Have I seen a 1 in this array? No. So we're going to add that to what I know. So I'm going to add that if there's an 8 at position 1, right? I go here. 11, well, 11 is not going to work at all because that's a negative number, but we'd have a negative number. We'd look for it. We can't find it, right? So we would add 11 and position 2 in here. Then when we get to the 7, we say, what's the number that I'm looking for that would match 7? I need a 2. So we look in here and we say, do we have a 2? And yes, we do. So what I need to know is what's the position that I found that 2 at? That position is 0. And I know the position of the number that I'm on. So I've got the solution, right? With just one pass through the array. So the key is that, and the reason why it's so efficient is because hash tables allow you to reference data based on this key. You don't have to know the position to go find it. They have a more efficient way of storing the information. This information is being stored actually in an array somewhere, but this may not be at position 0 or position 1 or position 2. But anytime I can find the key, if the key is there, I can very efficiently find the match that goes along with it. That's the benefit of this particular data structure, right? So first thing is, are you guys kind of following what the logic is about how to approach this? And look, here's the thing that I want you to understand. You know, you guys have gone through a really fast-paced learning curve of trying to know all this stuff. And trust me, people take a whole data structure semester-long class to understand all this stuff. So you're trying to take a little fast pace through it. And what I would actually encourage you to do in terms of these problems is, you know, try to look at it, try to figure out a solution. And then honestly, YouTube has lots of solutions to these problems. And looking at a solution on YouTube is a way of you learning about an approach to a problem, so that if you understand how hash maps are used in this particular problem, then now that becomes a part of your toolbox. And when you come across a different type of problem, you can now think about using that, right? Because you won't learn anything new just out of the blue. You've got to have some kind of experience, some kind of practice with it or whatever. But once it goes into your toolbox, it's a new thing that you can consider in future problems, right? So let's code this up. So it turns out it's not really complicated to code that way. It's really easy. So I'm going to comment out this brute force thing. And so we have to understand, how do we implement a hash map? And if I'm not sure about how to do that, I love W3 Schools. And I might go over here and go, you know, JavaScript.
Can I ask a question?
Yes, please.
So I know a hash map or hash table. I mean, like, I've seen this approach, and in JavaScript, isn't it just an object, or is that just referred to as a hash map? And like that's the terminology it's called, like, as that data structure is like an object in JavaScript, which basically stores key value pairs as properties in a data structure. Is
Yes,
that what it's just
what it
referred
is.
to?
So
Okay.
there's a hash map. So actually, maybe there's a hash map and a map. When I coded this, I used map.
You're in
So-
Java right now.
Thank you. So yeah, I said JavaScript, but it gave me did I type in JavaScript?
So it's true that while you search for that, there is a Yeah, JavaScript objects are internally a hash table. They don't have to be used as a hash table. Like a lot of times, of course, you use JavaScript objects just to store a fixed set of property names and things like that. But internally, they are using a hash table to make it efficient. So you can throw a lot of different properties into a regular JavaScript object, and use the keys to look up values, and everything that Pam talked about. The efficiency is true. But there's also, in more modern JavaScript, there are extended data structures like a map. That was a named data structure where you have to create a new map, and it has different ways of accessing the members. So she's got it on the screen now, but they are both like internally like hash tables, but it might be a little bit more efficient or a little bit more clear, like in your code, if you use the map data structure for something like this, as opposed to a regular JavaScript object.
Okay,
Yes, so this is what we're going to use. We're going to use the map. And a map is a data structure that can hold key value pairs. It says the keys can be any data type. And we've got some properties that go along with it. This is how I create a new map object. And notice there is this method called has that will tell me if a certain key is in that data structure. And if it is, if I want to get the value, I'm going to use this method called get. So those are the two main methods that we're going to have to use. All right. So over here, we're going to create a map. So here's my code here. Uh-oh, what happened to my what happened to my little side thing there? Mike, do you know how do I make my I don't know.
What happened?
I clicked on something in my little side window where all my files are.
Oh, maybe click the ... there. Oh, there it is. You got it. Click on that. I think you
There we
have
go.
the run and
Got
debug thing open. Yeah.
Got it. All right. So here we go. So we're going to set up a map. So I'm going to say, I'm going to call it, I called it num map, but so we'll do that. Num map is my map of my numbers equals a new map. So this is my object for this, right? So now we're going to loop through this array just one time. So we loop through the array. I equals 0. Actually, I called it X because I'm going to think of my pairs as XY. X equals 0, X less than nums.length, X plus plus. So talk to myself. What number do I need to make a match? Okay. I like doing this a lot. So I'm going to make a method. Let's say I'll call it need. Okay, that's the number I'm looking for, is going to be target minus this number that I'm looking at, which is nums of X, right? So that's the number that I need if this is going to be a part of solution. So now I need to know, have I seen this number, right? So we can check the map. So we say if num map dot has, if it has this number, the number that I'm looking for is need. This is going to return true or false based on if it finds it. So if I find it, if it returns true, I found the solution, right? And so what do? I need to get that value from there. I mean, I could do it directly, but I'm just making extra steps because as a teacher, I like kind of outlining every little step that I'm doing here. So y is equal to nummap.get. I need to get the value that is this particular, get the value that goes along with it. Okay. And then I just return that as an array, X comma Y. So that's what happens if I find a match, right? But if I don't find a match, now here's where a lot of times when you have if statements, you got to be careful and make sure like every if statement does not require an else. Okay, so, but in this case, because we have return, either way will kind of work. So if I get here, if I'm at this point, right, I have not found it yet, but what do I need to do? I need to add this number to the map because I might need it in the future. It might be part of a solution in the future, right? So we go nummap.add or set, I think. Let me go look at the, let's go look at our methods again really quickly for our maps. So if I want to assign a value, then I have to use set to do that, okay? So I do nummap.set that I want to say, and the value, the number that I'm looking at right now is nums x, and I want to put that in the map, and its position is x, right? And look, we can console log to kind of see what's going on. How about here? I'm going to console adding to map. So we can watch that as the numbers are being added. And we could actually make this thing make more numbers, but we can see that. And again, because the problem told us that there is a solution, we don't have to worry about returning something else outside of here. If there was a possibility that there wasn't a solution, then we would have to return something, -1, something like that, right? But we're guaranteed that there is a solution. So we'll save this and go find here. And we can watch and see what's going on. We added the 2, we added the 7, we added the 11. When we got to the last one, then we found that that was the one that we were looking for. If we change up, we can see the efficiency that, you know, if we find it sooner. Let me change the numbers in here a little bit. Let's say we've got 2, 7, 3, 8, and 5. And let's say we're looking for what? Let's look for 10. That'll be 8. And let's look for 5. That'll be 2 and 3. And we'll see that we'll add the 2, we'll add the 7. When we get to the 3, we'll have a solution and we won't even have to look anymore, right? So you see, we add the 2, we add the 7. When we got to the third number, that was the one that was the solution. And so that now gives us the solution to the problem. Yeah. All right. Questions, guys? So let's kind of talk through it a little bit. Talk to me.
Is there I was just wondering, because I had messaged you about this last week, because I kind of came up with a similar solution just using a regular JavaScript object. And then I went ahead and used the JavaScript map, which I really don't have experience with. And I was trying to find a good way to test which one was faster in performance. And I was trying to use performance.now, but I don't think the data set, the arrays I was providing for the problems, I think were too small to really show any discernible difference in time, because it was always like 0.000 something.
Yeah, you probably need tens of thousands of elements.
Right. I was wondering if there was any better way to test these kinds of functions without having to come up with some huge array, or maybe there's an easier way to do this.
Yeah, the timing is always difficult, like getting very high definition timers. Yeah, really the best way is to just come up with a data set where the times are in a range where you get a very repeatable results. So in this case, you probably need many thousands of elements, which you could generate randomly or something like that, you know, generate a random list of elements to test it out. But yeah,
Yeah, the only
There's-
thing with this one though, you got to make sure there's only one solution.
make sure it's exact, well, or a solution, and
Right.
depending on the random numbers, they might become very fast or they might be really slow. So yeah, so then you'd be statistically like generating. Well, if you run the two algorithms on the exact same array, then yeah, you'd be comparing apples to apples. But some of them
Right.
might just end up being fast because they're just by random chance the solution came up early in the array. Yeah,
Is-
there-
is- I'm
ahead.
sorry, I didn't mean to interrupt. Is there any performance issue that you guys are aware of in terms of using an object versus a map? Or is it pretty much, I mean, at least for something like this, it's negligible?
Yeah, I don't think there's too much difference. The one thing I will say though, that like using a JavaScript object, there's a slight chance of inadvertent keys. So when you have a map data structure, it's very clear, like it has 0 keys in it to start, and then everything in the map is exactly something you've added and
Mhm.
things like that. But there are, like, JavaScript being a very like open, flexible language, it has a lot of like built-in properties that are just always there. So like if you actually had a key called constructor or something like
Right.
that, or length, like there are some keys in there that like are just going to be the same name as built-in
Mm,
properties of a JavaScript object that you really don't want that to occur. So
okay.
if you really want your code to be correct, regardless of any sort of keys that you're passing it, the map would be a much better data structure because it doesn't have those kind of like, inadvertent properties that look like other regular properties that you've added.
Gotcha. Okay, thank you, guys.
And Alex, you were talking about doing something like this, like doing, if I did num map, just setting up an object like that. That's what you were talking about, right?
Exactly. That's how I came up with the solution, just using the regular object like that.
Yeah, yeah. But the nice thing is with these built-in data structures, you have things that are already there at your disposal. So
Right, like those methods has or get and all that stuff. It makes it really, really easy.
yeah, and they're already very efficient in terms of doing that. So look, this is a technique that you can use. Think about it in terms of other problems. Like if you need to sort of remember data that you've looked at so that you don't have to go through it twice, then this is what you can use as you're walking through the data. I might need this for something else. This is not the solution right now, but I want to remember it. Then you store it in a hash table, in a hash map. And that way you can easily get access to it without having to do like a search to find it. It's just a much more efficient way of doing that. All right. Yeah. All right. I see what you're saying. All right. So guys, look, talk to me. What do you think about? Do you want to talk more about, does the hash map concept make sense? And can you see some other application of that? We could have used it probably with the problem with the isogram. We could have, maybe, I have to think a second, might have been able to.
So I noticed when you was walking through it, you said, negative numbers won't get caught. So is it possible to use like the absolute value of the difference so that no matter which order you find the difference in, you'll still be able to get the solution and not a negative number you're looking for?
So that's where one of the first things though is, let's see, so we can have a negative number. So I don't know, is there a problem with negative numbers with this right now? Let's see. That's what we have to come up with.
Okay. No, I missed the constraint that you can have negative solutions. So
Yeah, that's what I just went back to look and see. So we always have to look and see what the problem is. So it does say in here that the numbers can be negative. And it still says that you can only have one solution. So we'd have to assume that, if we have negative numbers, I could have negative numbers and I could have a negative target, and that there would only be one solution to that. So I don't think there'd be a problem with the way it is right now, but that's something that we would need to just test and make sure. Yeah. So that's a really good, application of using a hash map and kind of what it's all about. Have any of you guys been working on any other problems that you want to talk about, or, tell us what else you've been working on? Because the key to this stuff is working on it, and I do want to say, some of you said you didn't start on it, and that's fine. I know from teaching, a lot of times there is just this, I don't know where to start. And the key is you have to start with something. And the other key is, you saw what I was doing here on paper. Sometimes that is really an important part of problem solving, is taking an example and just trying to think through, how would I solve this problem with paper and pencil? Computers are just tools that we use to solve problems. We have to come up with the steps to tell them what to do. So people were solving problems even before they had computers to actually do this. So you just got to start, and you start by just trying to think through, what would I do with these numbers, and how would I figure out what to do, right? So next week's, what I'm trying to do is, and maybe let me ask you guys, we were thinking today, do we need to, if I assign more than one problem in a week, do you guys think you'll work on more than one problem? Do you want to have more problems that you try to work on?
Definitely more problems, I think, would be amazing.
Yeah, so look, and no, you don't have to wait on me for more problems, right? LeetCode has lots of problems.
Absolutely.
And
But this is just fun too.
oh yeah, absolutely. So what I would like, if you're working on a problem, or if you get kind of stuck on something, let's use the Slack channel, that post it in there and say, here's a problem that I'm working on. Honestly, I'd like to not necessarily be the person that picks all the problems. If you guys are going through and finding problems, then post it in there and we'll add it to our list, and we'll talk about it during our weekly session. The other thing that I'm trying to do, I'm trying to also come up with problems that cover certain techniques of how to do things. So this particular problem covers a hash map technique. The problem for next week, actually, there's a lot of problems that sort of go in this, this type of problem. So next week's problem, just to talk about it real quickly, is, I'm not going to talk about how to do it, but find the longest substring without repeating characters. And this is an example of an algorithm, when we go through it, where you kind of have to keep 2 pointers to the array. You kind of have to, because you're going to be looking at substrings. So you need to look at 1 element and 2 elements and 3 elements. And so you kind of have to keep pointers to what's my beginning and what's my end. And so just know, sometimes it's frustrating because you think, you look at this problem and you just go, I don't know what to do, right? That's part of problem solving, is to just kind of dig in, kind of look at the numbers, and then do some research. Again, that's part of what's going on. I do want you guys to try to figure them out. But if you get really stuck on something, it's not a bad thing. It's part of your learning to go do some research, go find a way to do it, and use that to build your knowledge. Yeah. So that's the one that we will do next week. Anybody have any problems that you want to suggest that you've worked on or you've been working on that you want to suggest that we add to the list? Just post them in the Slack channel. Because there's so many. There's HackerRank, there's LeetCode, so many. So also don't feel overwhelmed by that. I can imagine that that is a little overwhelming, that there's so many problems out there. Start with the ones that are listed as easy problems, just to kind of build up your confidence, try to get used to how to do this stuff. And then, then you just work your way through. All right. So anything else you guys want to talk about with this or anything else? Are you starting to, we posted some stuff about the projects today. So you guys are gonna, hopefully, did everybody get that information and get assigned to a team or kind of know what you're gonna be doing in terms of a project? Or do you need any help with that? And there's office hours set up for a lot of different, technologies and different things. So as you're working on problems and you get stuck, we've got a lot of TAs that can help you with those sort of things. Okay. All right, we've got a little extra time. You guys talk to me and tell me, what else do you want to get out of this? What else can I do to help you in these sessions? Anybody got any suggestions or feedback?
I have feedback, Pamela.
Good.
I like doing this. I don't know if I could do 2 or 3 a week considering the project and work at the same time, but I like doing this. It's kind of challenging, especially when I take the function and try to create a little small dashboard. I have to add other functions and other things to it just to make it work. It's not as easy as just looking at the function and saying, oh, I could do that. No, you have to add more. So that's been fun and challenging. But and as far as the project goes, I already know what I'm doing. So I'm gonna pick up where another team left off and try to get most of the front end done. I don't know how. I'm gonna have to manage my time better. And I discovered Waka Time. I know Mike may already know about Waka Time. It's analytics that'll measure how much time you're using coding.
Oh, I don't know about
Yeah,
that.
yeah, you can use it with just about any coding platform.
W-
And boy, oh boy, now I know why I was burned out. I can't only imagine what it would have been over the past 6 months had I discovered it then.
Oh, interesting. Okay.
Yeah.
Cool. That sounds good. And yeah, Pia brought up a good point. And she actually made last week for the isograms,
Yeah.
she made a great little front end for it. Right now I'm kind of just focusing on the function, but that's another way that you can add on to this. So she made a great little front end where you input and then you do. I have to tell you, front end stuff is not my strong suit. So that's why I usually work on the functionality first and then come back and do it. But that's another way to add something to this, because as you guys are learning, just coding is just the more you do, the better you get. That's just the bottom line.
Also, we had Alex shared as something, what was it called? Exorcism.org. Is that like another coding example site?
Yeah, it's another like coding challenge website. But the cool thing about it is that for like there's a list of primary coding challenges, and when you complete one, somebody will review your solution with you. And the cool thing is you can sign up to be a mentor, and they express that you don't have to be a JavaScript master, but if you sign up to be a mentor, they encourage you to only mentor on problems that you have solved yourself. And, for me, I think one of the best ways that I learn, and I think most people learn, is by teaching. And so it's cool. I think, maybe going on there, solving some problems, and then maybe signing up to be a mentor and teaching people the problems that you've solved. They also give you like PDFs on things to look for each problem and the best solution and how to talk to
Awesome.
the mentees and stuff. I think it's great. It's
I'll
definitely
look at
different.
that. That's awesome.
Yeah,
Really cool.
This sounds really good. This definitely is, because, I was thinking maybe in the future, we really should just pick one of these platforms and, kind of, I don't know, set up a list of problems that we want you to kind of go through just for consistency or whatever, but this might be good. I'll take a look at it. Maybe we'll do some problems from here as well.
No, I didn't speak up earlier, but one thing that I would like to explore more is recursion. I know the simple basics of recursion, like I could set up a simple loop to loop through something recursively.
Yep.
But when it comes to solving a bit more complex problems using recursion and thinking in a recursive manner, it gets a little complicated. So maybe we could bring some of that stuff up. That would be cool.
That's a good
Yeah.
idea.
Yeah, I'll look into some recursive problems.
We could do quick sort.
Yeah,
It's a little advanced, but we could have like multiple problems. If we have multiple problems in a week, we could have one that's kind of an advanced one too. So
Oh, yeah, I mean, and I'm sure later down the line, we can go through all the different types of sorting algorithms and searching algorithms and those
Yeah.
kinds of.
yeah, but quick sort is a really good the idea of like recursion and quick sort, or find the kth largest element in an array, that sort of thing. They're really good recursive algorithms for those things. So that might be good samples for that.
so Ronald is asking where you can post a problem. Post it in our coding challenges channel in Slack. So that's the way, if you have a problem that you worked on or that you want us to work on, just post it over there. I'm moderating that channel, and I'm really happy and looking for you guys to give me some feedback on problems that you want to work on in there. Okay. All right, so I think we're going to kind of wrap up.
I had one other thing, Pam, just
Yeah.
it reminded me, like you were talking about the kind of extra things, like what Pia is doing with building, kind of almost a portfolio site showing sample problems she's done. One thing I do is I set up like unit tests and test cases, like using a framework. So any of you who are used to using like node.js, there's a framework which I happen to use, a testing framework called Mocha, M-O-C-H-A, and Chai is an asserting thing, assert language. So I'll post an example. I think last week I did some things with the symmetric differences. I think you had another side problem, Pam. I think you talked about symmetric differences, and so I had done something with that. So I'll post a link to just an example kind of unit testing. So like whenever you're building algorithms, it's really good to have like test cases and know how to write test cases. And so as kind of like an industry standard, this kind of testing frameworks are very common to use. You can set up test cases that you can run against your code all repeatedly as they change over time, and it gives you a lot of confidence that like when you need to like go reorganize your code, or like say maybe you're going to convert it from an object to a map or something, you already have all your test cases written, and then you can just run the test suite against your code to make sure that it's still working just like it was before, whenever you have to refactor your code or do some sort of change. So anyway, that would be a really, really good thing to practice. And it works best or easiest to do set up in like node.js. If anyone wants any help with that, let me know, and I can kind of walk you through how to set those up.
Yeah, that sounds good. So many things, so many tools, so much to learn. I know it can be a little overwhelming, but I tell my students, one of my favorite little things is, how do you eat an elephant? One bite at a time. It's all you can do, one bite at a time. So when you're feeling a little overwhelmed, just keep that in mind. Nobody knows all of this stuff, right, Mike? Sometimes I think you're close to it though, but but nobody knows all of it. So that's the wonderful thing about this environment that we have of information, because Mike and I were there in the good old days when you needed a reference manual. Like you had to go find a reference manual for whatever language it was or whatever, and you had to read through that. There was not this kind of access to information. So this really makes tech and problem solving and all this stuff a lot better. So anyway. All right, guys. Well, good. Well, thanks for everybody that joined. And again, please, post problems you're working on in the Slack channel, and we'll get a little conversation. We can have some little conversations going on there during the week about problems that you're working on. All right. And the new problem we've posted, I can give you, I'll put it over here as well. I'll put it in the chat. So this is the problem for next week. There's actually a number of problems that kind of are similar, but this is the one that we're going to work on that uses this particular technique.
And you're gonna
Okay.
post that in the coding challenges Slack too?
Yeah, I'll put it over there too. All right.
Great.
All
Yeah,
right,
'cause
guys.
We're about to lose this chat in a second, so.
Yeah, yeah. And anything else that comes up, you guys know we're just a Slack away. So just let us know we're here for you, okay?
We're slackers, I guess. Yeah,
Thank you, guys.
bad
All
joke.
right.
Thank you, guys. Have a
Thank
good
you.
night.
Thank you.
Bye,
Nice
everyone.
seeing you, everyone. Thank you, Pam.
All right, let me stop
Thank you.
recording.
Thank you. Bye.